Hi everyone, welcome to the 2020 Student Revision Tutorials Unit 3 Mathematical Methods with TI-Nspire, proudly brought to you by Texas Instruments Australia. We're going to look at functions and graphs today. This is part 1. The learning intentions for today's webinar will be we're going to look at the polynomial and rational functions. We're going to find some relevant features of the polynomial and rational functions using CAS. We're going to find the asymptotes and domain of the rational function, and we're going to look at some strategies for using CAS to solve exam-style questions. So welcome again for everyone who's tuning in. Now just to go over a definition or two, what's a polynomial? We all know a polynomial is an algebraic expression where the power of the variable is a positive whole number. In this section, we looked at linear, quadratic, cubic, and quartic functions, etc. When we're sketching graphs, we've got to look at the key features, which will include showing our axial intercepts, stationary points, points of inflection, coordinates of endpoints of restricted functions, and any asymptotes. And don't forget to put their equations on them. Make sure you read the questions carefully because quite often you don't have to show all those points. The question that everyone asks is, do we use a graphs page or a calculator page? Well, the graphs page was designed to find values of points of interest as a function as a decimal approximation. Calculator page, on the other hand, was designed to find exact values of points of interest of a function. And also you can convert those to decimal approximations. Looking at our first question, we've got to sketch the cubic there. We're going to show the coordinates of all relevant points correct to 3 decimal places. So we're going to enter the function, and I can press Ctrl G to bring up the entry line. And we've got x cubed minus 2x squared minus 5x and minus 5. The first thing you notice is the graph doesn't quite fit on the screen. So what we could do is we could go to Menu, Window Zoom, and we could go through the window settings. And I know you've all done that before, and you scroll down and you change them appropriately. The one that seems, from what we can see in our picture, was the negative value. So let's just change that. Let's just put in minus 15 for the sake of it. We press enter, and we see that we're sort of down near the bottom, but we may not quite have all of it there. But a new way of doing it would be if we just grab our pointer, we double click on the value there, and we change that to minus 25. And that gives us a better picture of the graph. We'll just move the label out of the way. Okay, now we're going to try and find some of these points of interest. So Menu, Analyze Graph, and we'll start with the zeros. And we'll go, we must move to the left side of it, click. Oops. Let's try that again. Analyze graph, 0. Tells us to work out the lower bound, so we just click there, left side, drag across, and there's our value. Now one thing we notice is this is not to 3 decimal places. So we'll just have a look at our settings. Remember that when you're on a different page of the calculator, you get a different menu. And we look at number 9, settings. At the moment, it's set to float. Now, it depends on the subject you're in and which you set to this. Float is for significant figures. Since our question was referring to 3 decimal places, we're going to pick fix 3, which means that all our values will now be correct to 3 decimal places and we don't have to worry about it. So we now see that it's changed. Let's go and have a look at another value. So Menu, Analyze Graph, let's look at our minimum. So this time we see our minimum somewhere in between 1 and 3. So I'm just going to press the number 1 and then press enter. Then I'm going to press the number 3 for my upper bound and then press enter. And it appears in the bottom hand of the screen. Sometimes that's a lot quicker to do. We go back to Analyze Graph. Now we're going to do our maximum, and we'll do it the same. Just drag across. There's our maximum. And this time, what we might do is use trace, graph trace. And if we just go across, we can see the y-intercept, and the values come down the bottom of the screen there. And if I press enter, they'll be put on the screen. Now we just have to move some of these out of the way. But first we'll turn off the tool, which is up there. And again, if you're not quite sure what the tool does, you can just go up into the top left hand of the screen and it'll tell you what's going on. So we'll just turn that off. And we're just going to drag the number out of the way a little bit and just move them so we can see. Okay. So now when we look at it, there might be one more relevant point that we might want to find, and that might be the point of inflection, which is somewhere in between the two stationary points that are there. So menu, Analyze Graph, and inflection. So again, we're going to click either side of it, and the inflection point is now listed. We now have all the points of interest that we require. Notice that because we send it to 3 decimal places, and our settings, that they're all to 3 decimal places automatically. Just a couple of notes here. For a cubic function, the x value of the point of inflection is the average of the x values of the 2 stationary points. So if we have a quick look, it's the average of the 2 x values of the 2 stationary points. So it's exactly halfway in between. The next thing, to increase or decrease the number of decimal places displayed, hover over the value with the pointer, a hand will appear, and then we just press the plus or minus accordingly. So let's just go back and try that. So if I hover over this value, then if I press the plus, it will increase the values. If I press a minus key, it will decrease the values. So that's a good handy tip to note. So this time we're going to sketch the Quartic, showing the coordinates of all axial intercepts and stationary points. One thing to notice in this question, it says nothing about decimal places. So therefore we're expected to, this time, find the exact values. So let's just have a look at the graph to start with. We've got our graph entry line, and we'll type it in. Plus 2x squared, 2x cubed, sorry. Plus squared, and minus 10x, and minus 5. Okay, there's our graph. Okay. Now, we notice that we're missing the bottom part of the graph again. So we're going to change the labels. This time what I'm going to do is I'm going to click the top label, and I'm just going to make that a nice round number. I'm going to make it 10. Instead of pressing enter, I'm actually going to hit tab. So I'm going to press tab, and then it moves to the right x value. And I'm going to make that a little bit smaller. Let's say about 6. If I press tab again, it goes to the bottom one. And to fit that in, we'll just make a guess, and let's say about minus 30. And if I hit tab again, it goes back to the other side, and let's make that about minus 6. And if I press enter, it turns the tool off. Now, if you notice, I was probably a bit generous with the scale down there, so we could easily just double click that again and make that minus 20. We've got a nice picture of the graph now. Okay. Now we said earlier that the graphs page gives us decimal approximations. We see that we've got one exact value on the x-intercept, but the other two aren't exact values. So we're going to move along to the next page. this is a calculator page. So what we're going to do is we're going to find the x-intercept first. So we go to our algebra, and I'm going to go to zeros. And if we press our var, we notice that we've got a function 1 and function 2. We put our second graph, the Quartic, in as function 2 and x. And we have to put what the variables, comma x, and we'll press enter, and we get our variables, their exact values. Now what I like about this is we don't have x equals and x equals or x equals. It's all nice and compact together. The next thing we might do is work out the x-intercept. Oh, sorry, the y-intercept. And therefore we go F2, and we just want to put in a 0. The next thing, we will work out the stationary points. Let's just have a quick look at our graph. So we know what this one is because it was an x-intercept, it's -2, so we have to work out the 2 minimum values. Now in this section, we haven't learned much about calculus, so we're going to do it with a calculator function. So we're going to go calculus, and we're going to, let's just get out of that for a minute. Well, we just have a look at the graph because we need to just look at the graph first. So we see that this first minimum is in between -2 and about -5. So we'll go menu, analyze graph. Go back to my calculator page. We're in our calculus menu. We're going to go to 7 minimum, and we're going to put in our function, which is F2. We'll put in our x. We're going to say what the variable is, and then we're going to go between, we've got to put the two values between, let's say between -3 and -1, and press enter. That's our x value. We also have to work out the y value. So let's bring up our variable. It's F2, and this time I'm going to press up arrow, and I'm going to press enter, and we see that it's also come with the x equals, but we could just highlight that and delete it, and then press enter, and there's our y value of that minimum. We now have to do the same with the other minimum, and we'll just go back to the graph and have a look. The other minimum appears somewhere between 1 and about 4. So we just have a quick look at the values we've got to put in. Now what we could do is we could go back into the history just using the up arrow key, because all we have to do is change a couple of values there. And we could just edit this now and put in a 1 and change this one to a 4. And we press enter. And there's our other value. We now have to work out the y value. So variable, F2, go up arrow, press enter. Now let's just see what happens if we do actually press enter with the x equals in there. We still get the value, but we get what the function is on the left-hand side. But this is our other value. And we can just scroll across to see what it is. So let's just go back and read the question before we move on. We had to sketch the graph of the Quartic, showing the coordinates of the axial intercepts and the stationary points. We did not have to work out the points of inflection this time. So it's all good. So what you do on your exam paper is you've got a picture of the graph, you've got your values to plot, and then label all the points on the graph. Okay, rational functions. Let's just go over a little bit of theory on that to remind us. Rational functions are in the form y equals a over x minus h to the power n plus k. Now for the hyperbola, n equals 1, for the truncus, n equals 2. When expressed in this form, the graph has, so if we can rearrange our equation into this form up here, we can read certain pieces of information off. Has a vertical asymptote at x equals h. We all know that the denominator, if we let that equal 0, it'll give us the vertical asymptote. When it's in this form, the horizontal asymptote is y equals h, which is the plus. In this case, it'll be plus k, I should say there. So that's a k in here. And the domain be all values except for h, and the hyperbola's range would be every value in R except for k. Now, if it was a truncus, we have a slightly different range. It's power 2, and we have to worry about the values being a is greater than 0 or a is less than 0. So we're asked here to sketch the graph of y equals 2x plus 7 on x minus 1. So we'll use the division template. And there's our graph. Now again, if you don't seem to like the scale that's chosen, the quickest way I think is just to double click on these and go around and change them. We'll just change the bottom Y one and we'll make that minus 20. Okay, we've got a better view and we'll just move that out of the way. So when we want to sketch the graph, a couple of things we work out. First, we could look at the x and the y intercept. So let's just go through and we'll use trace this time. I'll just graph trace. Straight away it pops up on the y-intercept, press enter and appears. And we'll just arrow across and see it comes up. All right, it says 0, so we know that that's our x-intercept. So if we just press enter, that will come up. So we've worked out those values. Turn off your tool up here by pressing escape. Just move these so they look in a nicer position. And now we have to think about the asymptotes that are there. Somewhere in here is one, and there's one somewhere above the x-axis. Just going back to here, if we look at the denominator of the equation, we know the first one would be x equals 1. So we probably wouldn't normally sketch that, but we could. So if we go to menu, graph entry edit, and we're going to go to relation, and we're going to put in x equals 1. Now we wouldn't normally put that in on the graph because we know where it is, but it's there. We could also, if we wanted to, look at the attributes of the graph and turn it into a dashed line. Now it actually looks like an asymptote. Remember, when you sketch your final graph, you must put the equation as well. So we need to work out our horizontal asymptote. So what we could do is we could go through our menu again, and let's go to some algebra. And if we go to expand, and our equation here, let's hit our var. Our equation is f1. We put an x in there, and just press enter, and it expands. And therefore, we have our y-asymptote because it's now in the required form that we spoke about at the start. We could go back to our graph now, and if we wanted to, we could put that in also. We'll just have to change back to function. And we'll put a 2 in there. There it is. If we wanted to, now what I'm doing here is known as a right mouse click. So on the handheld, it's control menu, attributes, and we'll just change that and make that dashed. Again. Okay, so that looks good. So there's our graph. Now, if you weren't quite sure that it was 2 was the horizontal asymptote, we could do something that we did last year in methods when we were doing limits. Because we know that when x approaches infinity, now the infinity is down on the pi button, and we put our function in, find that as x gets larger and larger, the graph will approach 2. We go back to our graph again. As x gets larger and larger, the graph comes down and approaches 2. Okay, so that's just a double check that we might use. Okay, now we're on to a couple of exam-style questions. Find the equation of the tangent line to the function y equals minus 2x squared minus 5x plus 6 at the point where x equals minus 2. So we could define our function. So this time, when I define it, I'm going to go F1. And I'm going to use, and put an x in there, I'm going to use the assign key. So control of the template, assign key, and enter. Now if we go back to our menu again, and if we go to our calculus, we look at number 9. Our calculus, number 9 says tangent line. So that's a nice little function there if you don't know about it. So one other thing I might do is just at the start, I'm going to make this look nice. I'm just going to go y equals. And I'm going to come back. I'm going to hit var and F1, x. And then calculus is going to find the tangent line, the graph, but we need to tell it where it's got to find this at. So I'm going to type, one of the syntaxes, I can just type x equals minus 2 and press enter. And there's our tangent line, the curve, which is a quadratic at x equals minus 2. We want to find the distance along the tangent line from the point of contact to the x-intercept. Okay, so let's have a look. What might we do for this one? So we had our y value back here. So we've got our equation. And what we could do is rearrange this to find where it is on the x-intercept. So let's do that. So we're going to go menu, algebra, solve 1. I'm just going to go back, and when we can go back in pages, we can actually copy things by here holding the shift down and pressing the arrow across, and then Control C. I go back to this page, and I'm in there. I can go Control V, so all those Microsoft commands work. And then we're going to solve for x, and we're going to go outside that, and we're going to use the given key. Given that, now if I press the back arrow, it goes straight down to the given key, and we want y to be 0, and press enter. So there's our x-intercept. The next thing we need to do is find a point on the actual graph where this occurs. So let's go var, F1, put in our -2, and press enter. So we've now got to find the distance from the point -2, 8 to -1493, 0. So it's good old Pythagoras. So -2, minus. Now I could go up in the history, go up arrow, select these values, and press enter, and it puts it back in there. I'm obviously going to have to delete off the minus the x there, and then we're going to go squared. Whoops. It's all highlighted, so it disappeared. So let's put the squared in now. And then, if you notice there, I pressed Control Escape or Control Undo to undo that. And then we've got our 8 minus 0. We don't need to put the 0 in. And then we've got to square that as well. And there's our distance from the point of contact, the tangent line, to the x-intercept. Moving along. Now, Truncus is defined by its maximal domain as a range of minus infinity to 4. Find the equation of the truncus if it passes through 2, 2 and 4, 2. So this says that the maximum value would be 4, and it's obviously inverted for the truncus. So we've got to work out the equation that's there. So, and just a bit of recall, there's the equation of the truncus, which is there. So the first thing we're going to do is define our function. So menu, 1, 1, define, and we'll call it f1x. Equals. Now I'm just going to go up here to save some time, and I'm going to copy this down. So highlight it. I can go Control C and then Control V. And there's our equation. Now the one thing we can do is we can put in the value. We know up here the maximum value is 4, and when it's in this form, k would be 4. So we're going to change that and put that to a 4. And press enter. We've defined it. Now what we've got to do is solve the equations. We could substitute both points into this equation and get an equation in A and H, but that's a bit time consuming and we're likely to make some errors there. So menu 3, 1, and we're going to, actually, I'm going to do that a different way, save a bit of time. We're going to go menu, algebra, solve systems equations, and we're going to solve this. Now we've got two equations. They're not in X and Y. They're in H and A, or A and H, so we'll change that to A and H. If we use that template, it puts in the variables for us. It saves a bit of time. We're now going to put in F1 of 2 equals 2, which is our first point. And the second point, we could hit var so we know what variables defined there. F1 of 4 equals 2. Okay, press enter. And now we've got the equation that is there. Okay, so the last thing, we'll just look at the last question, which is here. I'm looking at the time there. And what I'm going to do is I'm going to go to this file, which I have as an answer file. And we'll just quickly go through the last couple of questions that are there, parts of questions. Just talking about this, the files that you see before you, they will be ready to download. Just give 48 hours for everything and the video to be up for us. So we've got two functions, a cubic and a straight line, and we want to find the coordinates of the points. So if we drew out both the graphs, one thing to note that is not known so easily, if I go to menu, get down Yeah. If I go to menu and I go to geometry, there's a little known fact that if we go to the intersection points, if we go up here, intersection points, click on the first graph, then click on the second graph. Now we notice that there are 3 points of intersection. So if I clicked on the first graph and then clicked on the second graph, all of those 3 points of intersection automatically get put in there. Okay. And the calculator is already set to 2 decimal places, so they came up as 2 decimal. That's a nice thing to know. Just with the last part, we're just going to look at this. If you wanted to solve them yourself, you could put them both in and work out the values. And the second part of the question was, find the sum of the x values of the points of intersection. So if we take the zeros of f1x minus f12x, it lists all the values out. And remember, the zeros didn't have that x equals or x equals in there. And then what we can do, use the sum command, and it will just add all the values together, which are in this set of 3, and we get an answer of 3, which would be totally unexpected. So I'd just like to thank you all for tuning in on today. Give the last question to the panelists that are there, and we thank you for tuning in, and very shortly part 2 will occur. Thank you very much.